Hello everyone, today we're going to be working on example 5-6 and this example is asking us to calculate the reactions for the truss loaded as shown. So the first thing that we're going to do is we're going to see how many reactions we have in this example. Just one thing to keep in mind is you shouldn't be having more than 3 unknown reactions. So as you guys could see here, at point A, we have a pin support, meaning that we're going to have two reactions, the horizontal and vertical reaction. So I'm going to assume here that our vertical reaction is going to be acting upwards. We're going to call this A sub y. And then for our horizontal reaction, for our force in the x direction, I'm going to assume that it's going to be going to the left. We're going to call this A sub x. Now over here at point B, we have a roller support. So with this, we know we're only going to have that vertical reaction. I'm going to also assume that this one is going upwards. We're going to call this B sub y. So now that we determined all of the reactions, the next thing that I'm going to do now is I'm just going to be taking the sum of the forces in the y and the x direction to be able to determine the values of each of these reactions. So I'm going to start off with taking the sum of the forces in the x direction. So our sign convention, anything going to the right is positive. We know that the sum of our forces in the x direction have to equal 0. Here we assume that a sub x is going to the left, so that means it's going to be a negative a of x. And then from there we just have one other force in the x direction, which is the 5 kilonewtons. That one's acting to the right, meaning it's going to be positive. So plus 5 kilonewtons. And we know that that has to equal 0. We solve for a of x, and we end up getting a positive number, meaning that we assumed correctly. So the value of a of x is 5 kilonewtons acting to the left. So with that, we were able to determine one of the reactions. Now we're going to proceed to finding both of the vertical reactions. As you guys could see here, if we were to take the sum of the forces in the y direction right away, we would have two unknowns. So what I'm going to do instead is I'm going to be taking the sum of the moments about a point, so that way we could solve for only one of those reactions. So let's say if I were to take the sum of the moments about point A, we know that A sub y wouldn't be creating a moment, which is why we would then be able to solve for B sub y. Meanwhile, if we were to take the sum of the moments about point B, we know that B sub y wouldn't be creating a moment, and that way we'd be able to solve for A sub y. I'm going to be taking the sum of the moments about point A. So sign convention, counterclockwise, positive. We know that the sum of our moments about point A have to equal 0. From there, we know that a sub x is not going to be creating a moment. A sub y is also not going to be creating a moment. So now from there, I'm going to proceed to our 5 kilonewtons that we have here. Remember that moment is equal to the force times the distance. So here we have our force of 5 kilonewtons. And then that distance is going to be this 2 meters. We know that this has a length of 2 meters, so the distance is going to be 2 meters. And remember, this is creating a clockwise moment, meaning it's going to be a negative moment. So we have a negative moment of 5 kilonewtons times 2 meters. From there, we have our 6 kilonewton force acting downwards. We know that this one's also going to be creating that clockwise moment, meaning that it's going to be a negative moment. Once again, our force is of 6 kilonewtons, and we know that this distance right here is 2 meters. So we have a negative moment of 6 kilonewtons times 2 meters. From there, we have this 8 kilonewtons, once again creating that counterclockwise moment, meaning negative moment. We have a force of 8 kilonewtons and a distance of 4 meters. So once again, negative moment, force of 8 kilonewtons times 4 meters. And then lastly, we have our b sub y, which is the reaction that we're trying to determine. We know that b sub y is going to be creating that counterclockwise moment about point A since it is going upwards. So upwards, counterclockwise, positive moment. Our force is, well, we're trying to determine that. So b sub y, and then from there, a distance of 6 meters. So positive moment, b sub y times 6 meters. And we know that all of that has to equal 0. From here, we would end up getting negative 10 kilonewton meters minus 12 kilonewton meters minus 32 kilonewton meters plus 6by is equal to 0. If we were to solve this for b sub y, we would end up getting that b sub y is equal to 9 kilonewtons. And as you guys could see, we end up getting a positive number with that, meaning we assumed correctly. So we do know that that b sub y will be acting upwards. So with that, we were able to determine our second reaction. Now we have to determine one more reaction, which is our a sub y. So now that we know one of those vertical reactions, now we'll be able to determine the sum of our forces in the y direction, being able to solve for that a sub y. So if we were to take sum of the forces in our y direction, we know that we assume that a sub y is going to be it's going to be applying its force upwards. So that means positive. So we have a positive a sub y. From there, we have negative 6 kilonewtons, negative 8 kilonewtons, and we already know the value of b sub y. So negative 6 kilonewtons minus 8 kilonewtons, and we know that b sub y is going upwards, so plus 9 kilonewtons has to equal 0. So we end up getting that a sub y is equal to 5 kilonewtons. We ended up getting a positive number, meaning that we assumed correctly. So we know that a sub y will be acting upwards. And with that, we were able to determine all of our reactions for example 5-6. So once again, the first step that we took was just determining how many reactions we were going to be having. And then from there, just taking the sum of the forces in the x, the y, and taking the sum of a moment about a point to determine for the last reaction. Thank you guys so much for watching this video. If you guys liked watching this video, please feel free to hit that thumbs up button, and also please feel free to subscribe to our channel if you guys would like to see more videos like this.